Howdy and welcome back to the shop. Today we're going to be trying to put all of this goop here into this box. So this control box I built myself poorly. It is what it is. It'll do its job. We won't even go there. So we're continuing along with our Onan project. And this control box here is for this controller, and this is a Chinesium knockoff of a Deep Sea 6120. Now Deep Sea is up to Mark III or Mark IV on the 6120 controllers, and this would be a not in production anymore Revision A controller. It does not do nearly as much stuff as the 6120 latest revision, Mark III, I think. But it does kind of work. It does what I need it to do. So I'm not too terribly disappointed in this. I would have bought a Deep Sea, a genuine Deep Sea, but they were out of stock. It's amazing to me that the Chinese knockoff companies have got plenty of computer chips, but a good English, British-based company like Deep Sea, well, now they're owned by Jenner Junk, but Deep Sea can't get computer chips, but the Chinese knockoff crap keeps coming over here. Okay, rant over. All right, so the first major glob of spaghetti that we're going to throw in here is this fuse and relay box. Now, I bought this off of Fleabay. These are relatively inexpensive. There's no reason not to use these. As a matter of fact, I bought this whole thing cheaper than you could buy about three of these Bosch relays down at the parts house. So, 20 bucks for the whole shooting match. And it just makes everything nice, neatly organized. Well, neatly organized from the top, we shall say. So we'll get that stuff down in there and go to the next step. Okay, so I got that crammed in there. The next thing to go in is the main ground bus. Now, when I was fabbing this box, this is just a piece of 3/8 by 1 mild steel, and this is a piece of 7/8 copper that I hammered out flat, and I simply, whoop, that's backward. What did I do wrong here? Okay, more than one way to skin a cat. So what I did was I just simply bolted this down to this piece of bar stock and then started drilling holes, laid it out and drilled some equally spaced holes. And then once I got all the holes drilled, I took this off and then drilled for my clearance holes for my 1024s and my 1/4-inch bolts. And then broke off a tap in here while I was trying to tap these holes because, I mean, you got to break at least one tap off. So that is the main ground. Now, this box is bolted to the equipment, so you have a point of ground there. It's also grounded. There's about 3 different ways that this is grounded. So we should not have a problem with ground. But, you can't have, well, you can, but I like having a lot of ground. There is such a thing as too much ground and too many points of ground. But typically, if you bring all of your grounds back to one star ground, then you don't have a whole lot of troubles. And what I just put on there was dielectric grease, silicone grease, and that is to prevent corrosion. It does help, it does work. I like using it. Some people just absolutely go bananas if you cover things in silicone grease. But it does help connectors live longer, and especially ground points live a lot longer. So there's our regular old Ford starter relay installed. Now, This thing has points ignition, so this is different from the relays that are on like a Generac, the old R-panel Generacs. So this right here is actually a separate contact that your battery power comes in over here on this side. This is your enable. This goes straight to the coil. So this bypasses the ballast resistor. It gives you a hotter spark during the initial start, and this goes down to your starter lead. Now this machine does have its own solenoid on the starter, so really all this relay is doing is it's only handling about maybe 10 amps. But these little bitty Bosch relays won't handle that. And the way I set these up is every circuit that we're controlling here has its own relay and its own fuse. So here's this one is transfer switch. This case I'm going to be using a Generac transfer switch, so this controls the 23 wire going to ground. It isolates it from everything else. It just takes it straight to ground through this relay. So we've got a start relay, a run relay. We've got tied to the run relays, we've got a relay that feeds the voltage regulator. Then we've also got a relay that feeds an actuator that opens up a door that's going to be that way, opens up a door for a vent. So we've got that, and then we've got one spare in here. And, we've got a main fuse, we've got a battery, an onboard generator for charging the battery power source on the generator. So we've got a fuse for that. And then we've got various fuses. I think this is governor, this is actuator, this is fuel, I think this is start, and this one is going up to the controller itself. So everything has its own fuse, everything has its own relay. Now, none of the manufacturers do this for various reasons. I like it. It can lead to some troubleshooting issues, but it can also make troubleshooting really cool and easy. If you think you have a problem, all you got to do is pop out these relays and put a Noid in there, your Lone Wolf 9000 Noid light or Noid button, and you can actuate one relay at a time. So that's really handy. So we've got more stuff crammed in here, and now it's time to run some quick little tests on things. So I've got my my super duper Noid light hooked up here. So what we're doing, this Noid light, you're actually load testing with 2 amps right there and 4 amps right there. So that allows you to actually test your circuit with a little bit of load on it. And I'll put a link up here or something to where I built this Noid light. Real simple, real easy to configure. Just a nice little thing to have. So a thing that you have to consider when you're doing stuff like this, especially when you're using these rubber grommets instead of like a Romex connector or a cord grip or something like that, which it all kind of washes out, I guess. I don't like using cord grips unless I have to because they stick out, and then you've got something to hang your elbow on or walk by and break off with your hands. So if you'll take 2 zip ties, cut one short, stick it in there like that so that the knots on your zip ties end up being opposite each other at your cable. And then you end up with a nice little strain relief that doesn't cost hardly anything. I don't know how much a zip tie costs, but they're cheap. That's why everybody uses them. So you end up with a good strain relief that's easy to remove when you need to work on something. Oh, and get you one of these zip tie guns. Handy. But when you do this, you end up with a good strain relief. That's a pretty solid strain relief. Yeah, you can yank it through there if you're a ham-handed drunkie the clown. But it's pretty cheap and it works pretty good. Another thing to think of when you're putting stuff like this together is serviceability in the future. So what I've just put in here is basically studs. And this is where the AVR is bolted from the inside. Or not AVR, the governor is bolted right here, and then the AVR is in an enclosure that bolts onto the top, which we're not even going to go into that today. But this that gives me studs to where all I've got to do is put nuts on these studs after my AVRs, or my governor box is up there. So that makes it a lot easier to change this out in the field. You only need 1/3/8 socket. And I kind of thought this kind of stuff out, or I do think this stuff out, to where if I drop a nut when I'm working on this, it just goes to the bottom. It doesn't bounce around inside of something that's going to cook. So that's just a consideration if you're going to build something like this, is think about what's going to happen when you're having a bad day and you drop a nut. Are you going to have a worse day, or is it just going to be okay? So there we go. That's kind of the long and the short rubber. I've got everything inside the control box done. I've got to go through and double check all of my terminals, make sure I've got everything good and tight. Don't laugh, it happens. So, about the next thing to do is just plug the controller on, which is one of the greatest things about these controllers, is the way that they plug together and the ease in which you can get everything to break out. You know, it's really easy to back probe these and see what's going on if you're having trouble somewhere down the line. And I like to leave just enough extra slack that I can flip her upside down, get a hold of this, or flip her this way and get a hold of that. So that'll fit up in there like that, and it's got some nice little clippy clippers that clip the controller into the enclosure. And there you go. I think in the next video we'll get this mounted up, and I'll talk about some of the sensors, and then we'll look at the kind of a quick, dirty looking look at the programming that goes into these and the user interface. So till we meet again, y'all drive safe, watch for deer. What'd I do with them damn clips?